I can use the formula for finding areas of triangles to find areas of right, acute, and obtuse triangles. To find the area of a right triangle, we can actually use a rectangle. As we talked about earlier, you can find the area of this parallelogram by using the base times the height. Now if you notice, if we take this and actually fold it in half, we have made a right triangle. A right triangle is one where the height is directly perpendicular to the base. Now if we know the area of this, we know that the area of a triangle is exactly half that. So the formula we can use is half the base times the height, or the base times the height divided by 2. What that looks like is this. So make sure that you have these written down. This is the area equals half the base times the height, or the area equals the base times the height divided by 2. We're going to show both of these ways. If I'm on this one, it is going to be kind of tough to take half this base because it's a decimal number. So instead I'm going to use this formula. I'm going to multiply the base times the height, and when I'm done I'm going to have to divide it by 2. I'm going to do this kind of quickly just to save some time. Hopefully you're watching to make sure I'm not making any mistakes. Gotta put this to hold in my spot. I gotta put 2 of them to hold my place value. And then I'm gonna add it all up. And I have 201 and 78 hundredths, but that would be if I took the whole thing, because what I did was the base times the height. Now I'm going to actually take that and divide it by 2, because that's what my formula says to do. I want half of that parallelogram. I'm just going to use my shortcut way here. So I've got 139 centimeters squared. Now it's really important to know I used this because this was my height. I cannot use this. This tells me the hypotenuse. Since this is not directly perpendicular to the base, I can't use this length here. I have to use this one because that's totally perpendicular to my base. Now over here, if this is my triangle, same thing, I need one totally perpendicular to the base. I could call this the base, or I can call this the base. Either way, it's not going to matter because I'm multiplying those together. I'm going to actually use this as my base and say that I'm going to do this formula this time. Half the base is going to be 4. And if I multiply that times my height, I just have 4 times 6, which is 24 inches squared. It would be the same thing if I multiplied 8 times 6 and then divided it by 2. I would still end up with 24 inches squared. This is how I find the area of a right triangle. We're going to go ahead and look at a couple other situations here. How are these 2 triangles different? So if you notice the right triangle, there's that little box that tells me it's directly 90 degrees or straight perpendicular to the base. This one doesn't have that, so there's a couple of things I can do. I can either divide this into 2 right triangles and then add up those areas, or I can look at this as a parallelogram, and then I can notice that it's still exactly half of the whole thing. So I'm going to use that information to help me find area, and I'm actually going to solve it 2 different ways so that you can see that they're exactly the same. So first thing I can do is find the area of just this triangle right here, and then I'm going to add it to the area of this triangle. So I'm going to take half the base times the height. It's usually easier to do that way when you have whole numbers. So half the base is going to be 17, and I'm going to multiply that by my height, which is 32. So when I'm talking about this bigger triangle, it's 554 meters squared. Now I'm going to do the same thing over here, but I'm going to take half the base, that's going to be 6, and I'm going to multiply that times my height. This is just for this little smaller triangle. I've got 192 meters squared. So if I want to find this whole area, I'm going to take this and I'm going to add it to this. So 544 plus 192 is 736 meters squared. This is the area of that whole triangle because I added the two right triangles together. The other thing I could do is imagine that the whole thing is a large parallelogram, and then I'm going to take half the base times the height. So this time my base is all of this combined. So I actually have a base of 46, and my height is 32. Now I could take this, multiply it, and divide by 2. Instead, I'm actually going to take half the base right now. So half of 46 is actually 23. This will save me some time later. And then when I add it up, I should get, and I did, good, the same thing. It's a little bit faster usually to take half the base times the height of the whole triangle, or of the whole thing as if it were a parallelogram, rather than adding these two together. But as you can see, the formula is the same. It's still going to work. You just have to be able to identify where is your height. Because remember, this slanted line cannot be your height. It has to be directly perpendicular. We're going to look at just a couple more, and I'm going to talk from away from my screen for a second so that you can see what I'm talking about, and that way I don't have to keep walking back and forth on this next one, because the next slide is really short. What could you do about this shape? Could you find its area? If you notice, if I took a pen right now and actually just divided this into a bunch of different triangles, it would work for me to be able to find the area of the shape. Since I don't know a formula for area of pentagons, I could just divide it into 5 triangles that would be all the same size. Figure that out. If we're talking about what these triangles are, hopefully you know, but here's a quick reminder. A right triangle has a 90-degree angle. An acute triangle, all of these angles are less than 90 degrees. And in an obtuse triangle, you have one really large angle. It's bigger than 90 degrees. It's just a quick reminder. We've talked about how to find area of a right triangle and an acute triangle. And luckily, to find area for obtuse triangles, it's just the same formula. The only thing is we have to identify what is our height. So this is sort of difficult because it shows me all these numbers, but I don't need all those numbers. I need the base and I need the height. So hopefully you can see that the base of this triangle is just 8. But they had to extend it beyond 8 so that we can make it perpendicular to our base. So even though my base is just 8, I'm going to go ahead and write that. My height is this one way out here. It's outside my triangle because that's the only way I can get to something perpendicular to my base. So I can use either formula. I like half the base times the height when I have whole numbers just because it's a little bit easier to do. So half the base, and I'm going to go ahead and write that here, half the base is just 4. So if I take this and multiply it times my height, my answer is just going to be 48 feet squared. And you'll notice it's the same formula. So hopefully you feel like you now can identify and find the area of triangles, both obtuse, acute, and right triangles.